Okay, good morning, pre-calc kids. This is lesson 2.2, solving polynomial equations and inequalities. And this is Ms. Lefort. And we are going to look at this where, let's see, it tells us they're given the graph here, and they want us to factor this function and use the factors to find the zeros. So if we factor this, which we just did all these factoring yesterday, I'm on the wrong thing here, okay. So we factor, then let's see, I could factor out at GCF of x. So that gives me x squared plus x minus 6. And if we keep going, then this would be x plus 3, x minus 2. So that means as far as our zeros goes, our zeros are x is 0, x is negative 3, and x is 2, which we can clearly see on our graph because we've got negative 3 right here is a 0, 0, and 2. So that matches what we did algebraically. So now we're going to look at the graph and confirm that all these different parts. So f of x is equal to 0. This function is equal to 0 at the values of x equal to negative 3, x equal to 0, and x equal to 2. Basically what we just found. Now notice on number 2 it says f of x is greater than 0. So you're going to look at the picture and say, okay, where is it greater than 0? Well, I know it's greater than 0 in this part and this part. You see how it's above the x-axis right there? So it is greater than 0 on the interval from negative 3 to 0, and then again from 2 to infinity. Where is f of x less than 0 for part 3? So less than 0, well, that would be down here and down here on that part. So that would be from negative infinity all the way to negative 3, and then again from 0 to 2. Now number 4 is a little bit different because it says or equal to. It's greater than or it's equal to. So that means we're going to have some brackets on this one. So it's basically the same answer as number 2, except the brackets will be there. So it's equal to it at negative 3, so it has a bracket to 0, and it's equal there too, so that's another bracket. And then again, let's see, bracket 2 all the way to infinity. Now notice the infinity does not have a bracket. It never does, okay? It's not a specific number, so you just leave it as such. And then number 5, less than or equal to, is basically the same as number 3, just have brackets where it is equal to 0. So this is from negative infinity to negative 3, bracket, and then from bracket 0 to 2 on both of those. So let's look at another method here, or analytical method, to solve a polynomial inequality. If we have the picture, yeah, it's easy. I can just look at the picture and tell, but a lot of times we don't have the picture. So what do you do if you just have the equation? Okay, so this is the same one, so we know what the answers are going to be for part of this, but I want you to see algebraically what do you do. So first step is factored, if it's not factored already. And I know we just did this, but if we factored it all the way, this is x times x plus 3 times x minus 2, okay? And we're looking to see where it is greater than or equal to 0. So our zeros here would be x is 0, x is negative 3, and x is 2. So we're going to look at those. So what you do is draw like a number line, and there we go. And I'm just freehanding this. So negative 3, 0, and 2, okay, somewhere along there. And we have to actually test the intervals. So I am going to choose, let's see, just some easy numbers if possible. I'm going to choose negative 4. In this range, I'm going to choose negative 1. Here I'm going to choose 1. Here I'm going to choose 3. Just trying to find easy numbers. And when I go to plug this in, I'm not really concerned about the value. I'm more concerned about the sign of it, okay? So when I'm looking at this, I'm looking at this part, okay, the factored form, and trying to tell what sign that would be. So if I plug in negative 4, then that first one, it would just be -4, obviously. The second parentheses, x plus 3, if I plug in -4 right there, that's also going to be a negative. And then if I plug in a -4 on this last one, that's still going to be a negative. So I have 3 negatives. So I know this answer is negative. Then I'm going to do the same thing for each one of these little groups. So notice on x is -1. Well, that means the first one would be negative. Second one would be positive. Third one, that would be negative. So I have 2 negatives, so that's a positive. If I plug in 1, let's see, that's a positive, so positive, positive. The next one, that would be negative. So this is negative. And then if I plug in 3, I would get positive in the first one, positive in the second one, positive in the third one, so all positive, so that's positive. So now we have all the information we need to answer the question. So notice it's asking when is it greater than or equal to 0. So we're looking at when it is positive, right, or equal to 0. So I know that it would be going on the interval from -3 to 0, because that group is where it's positive right there, and also right here, which is from 2 to infinity. So when you're not given a graph, you need to algebraically test all the little intervals to see which ones would be positive, which ones would be negative, to know which one answers your question. All right, let's go on to the next page. Okay, so in this one, they give us a different function. This is g of x. It is pictured below, so that's kind of nice, but they want us to go ahead and factor it to figure it out, because notice that sometimes when they give us these graphs, it goes at the whole number of points, but not always. So you need to kind of know what that point is. I'm noticing there between 1 and 2, there's something, we don't know exactly what that point is. So let's go ahead and factor. So let's see, I could factor out, let's see, it's 4 terms, so I got to use grouping. So I'm going to group the first 2 together, group the second 2 together. Oops, why did I put a negative right there? It's not a negative data. Okay, factor out GCF of each one separately. So on the first one, I can factor out a negative x squared. So that would give me x plus 3. On the second one, I could factor out a 2, and that'll give me x plus 3. And remember, these things need to match. If they don't, you can't use grouping. So what do they have in common? They both have an x plus 3. So what would be left if I take that out? Negative x squared plus 2. So I know that x plus 3 is 0, so x would be equal to -3. And on this other one, I'd get negative x squared plus 2 equals 0. So x squared is equal to 2. So x is a positive or negative square root of 2. So these are my zeros. So when I look at the graph, I can clearly see the -3. That's easy enough. But this point must be my negative square root of 2. And this must be my positive square root of 2. So the zeros are at x equal to -3, x equal negative square root of 2, and x equals square root of 2. All right, now that we have that, the zeros, then g of x is greater than 0. Greater than 0 would be here, and then on this part, because that's above the x-axis there. So we're going from -infinity all the way to -3, and then again from negative square root of 2 to square root of 2. I'm going to go ahead and skip down to number 4, because it's almost the same as number 2. It just has the brackets. So I know that one's from -infinity to -3 bracket, and then bracket negative square root of 2 to positive square root of 2. Bracket. Okay. Now, number 3, they want to know where it's less than 0. Well, everything that we didn't mark so far, that's obviously between -3 to negative square root of 2, and then again from square root of 2 to infinity. And then number 5 is almost the same thing. It just has the brackets because it's got the or equal to, so -3 to negative square root of 2, and then again from square root of 2 to infinity, like that. So when we're looking at it analytically, okay, this is just the equation, our inequality, no graph. You factor it just like we did before. We already know that this goes to, I'm just going to write it in. This would be x plus 3 times 2 minus x squared. I went ahead and rearranged those. So my zeros would be x equal to negative 3, x equal to negative square root of 2, and x equals square root of 2. So when I'm drawing my number line here, okay, I got a negative 3 here. This is negative square root of 2 and square root of 2 over here. So I'm going to choose, let's say x is negative 4, x is negative 2, x is, well, actually I could use 0 right there. Might as well, right? I'm going to use the easiest thing I can. If you're not sure what the square root of 2 is, you can just plug that in your calculator, get a decimal, and pick something in between the two. You know, just make sure you get between it. And then let's see, this would be x equals 4. All right, so if I plug these in, now remember, these are my zeros here, okay? So these are my key values. I'm picking numbers in between them. So if I plug that into this and figure out, do I get a positive or a negative? So if I plug in a negative 4, then this would be a negative. The next one, that would still be a negative. Okay, so this is a positive. If I plug in negative 2 there, I would get a positive here and a negative, so this is a negative. If I plug in 0, this would give me a positive times a positive, which is a positive. And then if I plug in 4, I'd have a positive on the first one, a negative on the second one, so this is negative. All right, so let's answer our question. We have all the information we need. Where is it less than 0? It is less than 0 where it's negative, okay? So this range and this range. So that means it would be from negative 3 to negative square root of 2, and then again from square root of 2 to infinity. So notice how our algebra confirmed what we found in the graph. All right, so this next one is h of x, and it is already factored for us, which is very nice. So we know that, oh look, that one's squared. So remember, this is like negative x times x plus 2 times x minus 2 times x minus 2 is less than or equal to 0. So, you know, if you need to write it out, you can write it out. You don't have to. It really doesn't matter to me. But I know that our zeros are 0, negative 2, and positive 2. So when I have my number line here, negative 2, 0, and 2, then the ones that I'm testing, I'm going to test, let's say x is negative 3, x is negative 1, x is 1, x is 3, to figure that out. Oh, let's see, negative 3. So negative, negative, that would be a positive on that first parentheses. Next one would be a negative. And then I can either do like negative squared, or I can just write negative, negative. Like I can write two of them. You know, your choice, whatever works for you. But I know there are 1, 2, 3 negatives right here, so this is a negative. On the middle section, if I plug in negative 1, that's going to give me a positive on the first one, positive on the second, negative, negative. So it's even number of negatives, so that's a positive. If I plug in 1, that would be a negative, positive, negative, negative. Okay, 3 negatives, that's a negative. And then if I plug in 3, that gives me a negative times a positive times a positive times a positive. Oh, I'm running out of room over here. Positive squared. Okay, so this would be a negative. All right, so this is asking us, where is it less than or equal to 0? So less than or equal to 0. Less than 0 here, less than 0 here, less than 0 there, or equal to will be our actual points. So that means we're going from negative infinity all the way to negative 2, bracket, and then from 0 to infinity, because we can include that too. Everything is included. All right, so let's look at the graph. So notice on the graph, you see how the analysis is confirmed by our graph? And I want you to notice that when you have something like this where x is 2, and you see how it stays on the same side of the x-axis. It just kind of touches the x-axis. This has a multiplicity of 2. It doesn't cross. It's an even numbered multiplicity. So that comes in handy. And if you notice, we had it squared up above. So that factor was squared. So when you know the multiplicities of it, it helps you to know what the graph is going to look like. Now, how would your solution to the above inequality be different had the original equality been that greater than or equal to 0? Then we would look for what's above or actually on the inequality. So the answer on this one, because it's greater than, okay, so it's different than less than, then I would be looking at, let's see, greater than, I would be looking at all of this part. Oh, and this 1 point. So it would be from -2 to 0, and we'd have to say x equal to 2 because of the or equal to. And that's a part that catches a lot of people, and they miss it on the test. It's caught me before too, so just be careful with that. All right, our last page. Consider this polynomial. Okay, we have this inequality, x cubed minus 9x is greater than or equal to 3. What do you notice about this polynomial as opposed to the previous examples? Okay, so what they're wanting you to see is, you see right there, that is not 0. You can't do this if it's not 0 right there, okay? You have to have it equal to 0 because we're looking at the number line, the x-axis, basically. So you would need to move that 3 over to solve this. So 9x minus 9x minus 3 is greater than or equal to 0. Now I could essentially use this, okay, to solve. Turns out this one is not factorable, so it's kind of crazy. We would need to use our calculator for it, which, yes, you can. You can rely on the graphing calculator. So let's look at that graph right now. So if you have your graphing calculator, type it in. If you don't, you can go to Calculate 84. I was just told about this, Calculate 84. It's very similar to the TI-84s that we have in class. So if you don't have one, you can kind of look that up. It's an app or a website or something. You should be able to type it in and see what the graphing calculator is, kind of like Desmos, but you know, so you can do it. But if you're using Desmos, you can't use your iPad like on a test or anything. But if you're using the Calculate 84 and it's the buttons are very similar to those on an TI-84 that you can use for the test, you'll be more familiar with how to use it. So I would suggest looking that up if you don't have one at home. All right, so if we had graphed it, arranged inequalities so that all monomials on one side, okay, graph on the graphing calculator. Okay, I'm going to just kind of sketch it in, okay? So I pulled it up on my calculator, and I found out that one of the 3 zeros is x equal -2.817, x equal to 3.155, and x equal to -0.338. Okay, I looked that up. I typed it in. I went to the table, found all my zeros. So if I plot these, and it's not going to be exact, y'all, so be nice. Okay, so this is 3, a little after 3, a negative, but not very far negative, and then almost -3. Okay, something like this. Well, I notice on mine, it kind of goes like this and like this. Okay, so yours is probably much better than mine, but that's kind of a little sketch of what it looks like. So graphically, what does the solution to that inequality represent? What would those intervals of solution be? Okay, so graphically, it's everything above the x-axis. If I look at the picture, and you got to be able to find the zeros to be able to write those intervals. So here, that would be bracket -2.817 all the way to -0.338, and then again from 3.155 to infinity. So notice I went 3 places after. Normally on the AP calculus classes, they always go to 3, they grade to 3 decimal places. So we're going to try to do that in AP Calc, pre-AP Calc, so you're getting used to that. So 3 decimal places. All right, we are done this lesson, and now you can work on the homework. Well, actually, that homework will be tomorrow's class period's assignment. And I will answer any questions you have when we meet next time.